Okay, we're in cohort 6 point question mark and discussing some applying active inference questions. And Jeff has turned us to the inspiration topic. So where were we, Jeff, or continue?
Yeah, several of us, Dean Tickles and Anna Magdalena Hurtado and Hector Manriquez, we've been going back and forth for about 2 weeks on what inspiration means through the lens of active inference. And for me, inspiration, and I think this is a really good definition, and I think Dean offered this up, and it was what happens when you have a new model or a new artifact that has no through line, no uh, contiguity for how you receive, how you arrived at that specific phenomena or experience or bit of information, right? It is that is seemingly without cause.
Okay, lot of ways we can model it. Just are there any more general comments or definitions or thoughts? And then otherwise, we're going to kind of walk this pseudo chapter six path for how we would move towards structuring it.
You're basically asking like how does like insight arise into like the shape of some like object you're looking at or some insight you're looking at? Is that what that last question was?
Zach?
Yeah, this reminds me of really core active inference, right? Whenever you're talking about like if you just have a whole bunch of particles, you can differentiate the states that the particles are in by the states that seem to have this kind of sub thing going on and the maintenance of the sub thing. And this thing wants, by virtue of existing, very core definition of active inference, right? Or I'm sorry, the I'm forgetting the word of it, though it's a very important word. The idea that because it exists, we can talk about the dynamics of it existing. I'm sorry, I can rephrase that if you
Yeah,
need. I did not
yeah.
say that very well.
Conditioning modeling of something on that thing being like existing or measured.
Yes, absolutely. And so it's going to maintain its own state. But the question I have is, could you guys describe the no through line or continuity? Because by saying that it is a thing, aren't we already talking about it has a thingness about it? We are already talking about some states where it is instead of some states where it is not.
Yeah, like even a really inspired new line of poetry. It's like it may have a chain of causation. So then if we were tasked to make an active inference model, and in that first question, chapter six, like what system are we modeling? It's like what question are we trying to explore? Are we trying to reify our definition or observation that inspiration is that arrives at without a cause? Or are we looking to quantify like some index of inspiration where on the lower end there's like complete continuity and then on the upper end there's less continuity? Here's one older paper with the kind of more on the insight. Okay. So from chapter 6, we have those 4 stages of the question. Let's just answer the first question, and then we'll look over to a few other kind of tools for modeling. But what system are we going to model? Like, could we pick some specific inspiration setting just to make it clearer?
A song comes to an artist in a dream.
Okay. Here, I'm going to pop over to this other active block inference coda, just because it complements the chapter 6. So in the textbook, chapter 6 gives these 4 steps that suffice to design active inference generative model. So big picture, the first part is like system of interest identification, systems engineering, systems modeling. Then you get into the kind of chapter 4, chapter 7 and 8 questions. Like, is it going to be a discrete time or continuous time? What kinds of state spaces are the variables? And then question 3 and 4 are about setting up basically the agent and the niche. And this is dealt with at a pretty overview level in the textbook. And depending on how complicated the setting is, that this can be like very straightforward, like thermostat and the room, or this might be really sophisticated, like having a bunch of nestmates in a colony. But here's just a few compliments to those lists. Here's from the block front side. The cognitive modeling side. First off, the settings, many discussions over the years and sub discussions and things like that people have brought up, but just focusing on the recipe. This kind of just gives a little bit of a different flavor, which is first take a structural approach to the project. Like, it asks a few more background questions about what is being addressed and not. Then this was like some of the earliest memes with Jakob, which was like, we're map building with these cognitive models, and then we're playing with this like deriving, because you could derive something as kind of like to squeeze out, but then also it means to take the derivative. And then there's different notations for the derivative. Like sometimes it's a dot, or it's a prime, or it's like f prime of x. So then if we derive a model, but then there's different notations for the model, and then the table that I'll copy back into our textbook group, this, I'll just take it from the ant model. Okay. Here are active inference ontology terms. I'll delete these columns. And their notation. So we see A, B, C, D, E, pi, A, O, S. And then here we'll do artist generative model. Once we fill out these cells for, like, if we're going to use a discrete time model, then we'll basically have all the variables we need. But this is just a way to use the ontology to scaffold making a generative model, because basically you just fill out what would these things be for that situation, and then already just manually or with a LLM there's enough information to get you to the POMDP. Okay. What should the observations be?
What the components of the song, I suppose.
Yeah. This is like part of that beginning, going from the qualitative and starting to give some structure. It's like, is it going to be just a sound model? And then how many layers to go into detail? But that's kind of that journey, is to take the um pre-structured situation, like just situation as it is, or not explicitly categorized situation, and then be like, what are we going to pull out as observations for whom? So it's like, will there be a bodily awareness? Will there be a time awareness? If we're going to ask a question about time, then I mean, we may need that to be explicitly included, but maybe it's not in the observations. Let's start with just music sound, and we can figure out what types. Okay, what hidden states are being inferred? So what are unobserved but hidden causal factors that actually exist or are proposed to exist?
If there's lyrics, then you have to suppose the understanding of the language. Same with instruments, right? You have to have a model of which sounds, or at least how you can instrument the sounds that you, yeah, how you can instrument the sounds.
There's also an interesting piece there with this, if we're going to come back to the time perception, because music has a time rate, but like a architectural vision or something, that might be static, or so then, but the song, I mean, does the artist hear the song at 1x speed, or do they hear it like faster or slower? And then what if it's not possible to be played?
Or do they get it partially and then fill the rest of it in when they wake up?
Yeah, true underlying song. Like it sounded like they were underwater, but I heard something.
Mm-hmm.
Okay. Let's just also, just to be clear with the letters, and I'll just bring it over. Okay. So we have some observations coming in. At the very least, music, possibly some time observations, or some rhythm. In the S, we have two kinds of S's. States related to the music, and then states related to the flow of time. Okay. What does that give for the A matrix then? The simplest answer is A is mapping between S and O, whatever those are. So that could be pure intra domain. So that would be like sound O maps to sound S, time O maps to time S. So in that situation, there'd be like two separate S variables. They could be different shapes. And then each of them has an A leading to separate O variables. Or there can be more of a domain fusion, like single S with mapping to sound O and sound and time O. I mean, this is like why it's just like get it down and like kind of iterate over it. It's like, oh, because like what is the time observation? It's like, well, is that an internal observation? Is that a metronome? Is that a breathing? So it's like we can kind of run back over and check for a consistency, but basically A is going to do whatever intermediation work is required to get from O to S. But this is the sense making partially observable elements that's going to go from whatever you're saying is data as measured to variables as proposed.
Just thinking of like another ingredient, like sometimes as a musician, you can like feel the song in terms of like how you hear it, more like through your spine or like energetically, but then you might also like that might get mapped to how it feels for like to play the song. You might have some kind of intuition of like the fretboard or whatever it is.
Yeah, that's good idea, like using kind of like intermodal heuristics. Like this cake is going to taste good because I just touched it and it's bouncy. So then there could be, in that situation, that would be more like the domain fusion for A, because you'd have like the latent state would be like quality of the cake. And then it'd be like, here's how the color profile is associated with it. And then here's how the touch, here's how the springiness is associated with that latent variable of cake quality. But then in the dark room, you still could use the touch modality to assess the cake quality. Okay. Let's move pi up. So what actions are being modeled as being taken? Actions are going to intervene. They're going to pick out a slice of B, and then the chosen slice of B is going to be used to control the time evolution of S. So again, kind of an interesting case. Like, what are the actions in this situation where the inspiration is putting on a show for the artist? What action selection are we looking at for them?
So I can get grounding. Are we saying like the action is like basically like as the dreamers like as the person's like waking up from the dream and trying to like grasp onto the song and solidify it, or is this like a different kind of question?
We can make this really like non-physical, right? Because it's coming from a dream. Therefore, we can say, well, could we say that like one of the actions is changing our model of the world, as in now I want to make this song before I did not want to, but then I had the dream, which is a perception, and the action I take is the desire to make this thing in reality.
Okay, yeah. Let's get some of those. So let's just say that one kind of action would be if S equals motivation to make song, pi would be so through time there's this motivation to make some song, and then there's B that simple two options for B. Either keep your motivation where it was or increase your motivation would be choosing to increase motivation. I mean, obviously other ways to model that too. Here, if S, Martin brought up this like waking up. There's modeling of attention as action. That's some of the work with Lars Sandved Smith, where internal action policies, covert action policies, are modeled as attention. So this is like S would be, what am I paying attention to? And then pi is a policy on what is being attended to. But kind of using this POMDP skeleton like our recipe outline, it's like whatever S is, there's going to be some S's that don't have direct policy control. Those are called uncontrollable states, like in PyMDP. And then there are the S that are controllable, which means that their B's, their unfolding is controlled by B's that have some policy efficacy. But then this dream setting kind of stretches the case, because it's like, is this a lucid dream where the person is seeking to is it really them from behind the veil inspiring themselves, but then obscuring that it was them? But then this goes back to that first question of chapter 6, which is like, which system are we modeling? And in active inference, just like anywhere else people have done systems modeling, that's not necessarily trivial, because once you start tracing the physical and the informational exchanges of a system, you can, you tug on one part of the world, then everything else comes along with it. So that does become the question, like which modalities to restrict to. On the other hand, a great strength of active inference is that if the models are constructed appropriately, at least they'll be interoperable. Like you can say, we're making just the dream auditory track, and then just the dream proprioception track. And then you could test those two models separately. And then you could more easily also fuse those models, see if there was like synergistic outcomes. So there's still a lot of possible modeling, but at least what you make may be more interoperable. Let's see what other S could be.
Get an idea of like the framing here. Maybe it's a dumb question, but the pi is like some kind of like action that changes the state, but does that also like create the flow of time in a sense that like it's just how states change over time?
Yeah, great question. Just the narrower answer is pi is a probability distribution over policies. Policies are the affordances that can be taken in a given moment over the given time horizon. So if there's no planning, then pi are just the actions that can be taken in the next moment, which are the affordances, like up, down, left, right. If there is planning, then pi starts getting bigger, like exponentially bigger with the time horizon, like 2 time steps. If there was 4 affordances, there'd be 16 options in pi. So pi is a probability distribution. It sums to 1 because some action is taken. And then depending on which of those indexed policies are selected, that's which B transition operator is chosen. and then that's what controls how S at t minus 1 goes to S of t.
Okay.
So, but then when it comes to modeling, it's like, and again, time perception is another fun and interesting case, but it's like it doesn't reach in directly and change the temperature of the room. It's like temperature of the room at the previous time, and then you decide turn on the air conditioner or not. And then if you choose to turn on the air conditioner, then you got the prior temperature, turn on the air conditioner, and that results in the next temperature. So it's not that pi directly like goes in and changes the temperature in the room, but it acts through this B.
Perfect. Yeah, appreciate that.
Where and there have been a few time perception active inference papers. I'll try to find.
Yeah, we're definitely playing with the weird system because time perception and dreams changes.
Okay, here's Bogota and Jubera. I forget which number we can look, but it was a live stream previously. So here they're using the Husserlian phenomenology ontology. So retention is what is retained or sedimented from the past. Protension is what is anticipated into the future. So this is kind of like the thickness of the present, where like what was anticipated moves through the present into the and then parts of it becomes retained. Now, here, okay, this might help us. See here, okay, font looks a little bit odd, but this is state S O. This is basically the table. Oop. Don't know where the table went, but this is basically what the table is, and this is like this is what applying active inference looks like in this setting where we're doing the A, B, C, D, E, S, O. It's about defining what those variables look like for the given system or question of interest.
Is it just me, or does that look a lot like relativity, except the gamma term has been replaced by a probability distribution?
Which part?
Mostly that first graph that you showed, where there was that kind of diagonal set of squares. That's what really set it off for me. And talking about the object time versus the model time, using tau and t, that was another thing that made it really seem similar. That one right there, exactly.
So what would this be like in relativity?
That would be changing reference frames, which would mean that like they are perceiving space and time differently than a different observer would. Which is to say that like one person at point B would look at something and say, oh, maybe top left D would look at something and be like, oh, I see two events in two different points in space. They happen at time one and time two. But at person point A of T to the far left would look at those same two events and say, no, they didn't happen at time one and time two. They happened at time three and time four. They would happen at relatively different times because their experience of time would be slightly different.
Oh, yes, I see this. Like, or it could be like, here's message 1, 2, and 3. Person A has gotten none of them. person B has like, yeah, I got message 1, but I'm just getting message 2 now. But then for this person, they were closest to this. I don't know if that's exactly how it's laid out here, but it's like already for them, the messages are in the past. But for someone else, those messages haven't even happened yet.
Yes, exactly. The time is relative.
Okay. We'll see what we can bring back into the model, but also looks kind of like a fretboard, like a diagonal line on a fretboard for a bass.
Oh, it totally does.
We can make him song compression. Okay, that I mean
Was that just an example of inspiration there?
It might have been.
I don't know. It looks like it. And also this is kind of related to Hector and Michael Walker's work on the side by side in the zone of bounded surprisal, which is like there's the question of the insight to one agent, and then also there's the question of like whether it can be observed and whether that can be transmitted. Like just to make it more concrete, they're studying these flaked rock artifacts that like sort of human ancestors made, and then they're always like popping up, but then they go away. But like it will have been made a certain way, but then it's not transmitted how it was made. So just because something can be seen by one doesn't make it seen by another. Let's just see if there's any other pieces to this paper, and then we'll return to where we were. I mean, this is there's obviously a lot to it here, and they're going into they're kind of bridging the Husserlian phenomenology with the future, present, and past with the ActInf style. But that's kind of the meta recipe, which is combine the ActInf ontology, the letters and the functions and the methods that we know, with some other domain. Time consciousness is kind of a particularly there's it has it, because the measurements come through another modality. There's not like a proximate time sense. Like you could have a vibrating clock or a metronome or breathing, but then the time inference is something that's added on to some other modality. Whereas in sound, it's like sound observation, and then you're observing a sound latent state. Let's just pick one kind of policy to model. If S were true song tempo, pi would be speed up, stay same. Let's just say that it's a lucid dreamer with this limited kind of control over the music that they're hearing. They can change the tempo. So if pi has 3 elements for slow down, stay the same, or speed up. So this would just be like a simple vector with 3 cells. If it were uniform, it'd be like 1/3, 1/3, 1/3. C, these are preferences. So does the person have a preference for the observations?
Is that kind of like if the song seems salient to them, they'll try to like remember it or something like that, or just kind of preference of what the song feels like?
Yeah. I mean, it would have to be sketched out, but what this is going to go, this is going to load on pragmatic value. C is basically is 100% where pragmatic value gets specified. If C is flat, then there's no pragmatic value in the generative model. You only have epistemic value. So it's kind of interesting, like, yeah, is the song recognized as valuable because it's what they prefer, or is it recognized as insightful because it is recognized as novel? Something could be both novel and preferred. However, if you recognized to the extent that you recognize it as part of your prior preference, that would not be novel.
Or if there's like notice that there's some kind of like beauty to it and the sense of like truth, beauty, and goodness, like it's maybe some kind of meta structure that has some geometry to it.
Yep. I mean, this is why why in the textbook it's like the T maze and the simpler cases, because once we're dealing with a kind of mental kernel that has these that for any input is going to start exploring like good, true, beautiful, structured, etc., then it's like it kind of makes the sensory inputs just a small piece of the picture. Whereas in the textbook examples, it's a very kind of closed form model where you can trace exactly how the observations relate to like changes in the model's behavior. So D, this is the prior on hidden state. So if we're going with S is the song tempo, let's just say prior on initial S. So this is kind of like interesting. Maybe even the song tempo could relate to the time and the rhythm. So it's like if we're hearing sounds, we hear one beat. So, but we haven't heard a second beat yet. So we can't yet estimate how fast the song is. So all you have is the prior on the song. That would be right when you're right here.
Right. Yeah.
E, this is the habit. That habit. This is prior on policy. It's not it's right here. E. So this could be uniform or not, but basically it's just your prior on policy. And then A is the action, but it's what policy selects. Okay. Then what about the generative process? Again, this is a very interesting question where it can go like back and forth between sketching out a little bit about the agent, then going back to the niche. Like, so what is the niche of this artist that we've been sketching out?
Do you mean by niche, like a musical niche, like the genres they like, or something different?
Um, I think it could be. Um, I'm just gonna go to the paper with the attention. Look, like just just generically, the observations that the artist is getting are coming from the niche. And then the actions that the artist is emitting are being received by the niche. So it's just that's when you plug in the agent model into the niche. So that can be like in the case of sensory data and action, like bodily overt action, that is sometimes related to the physical niche. Like it's getting thermometer observations from the room and then it's sending control signals to the air conditioner. But then, for example, this is the model where policy is attention. Here, like here, let's look at this top level attention. Let's look at, okay, just the 2-level model. Okay. The blue is the proximate sensory. So this could be like visual data from the eye. And then here is on the orange levels nested model. It has the same structure as the POMDP, except come in an SA, and then instead of SAO, instead of like what shape is or what color am I seeing, and then what are the raw pixel data coming in? That's the primary proximate visual layer. But now here the SA, but then the observation that this higher order agent, basically this metacognitive agent is receiving, is related to the precision or attention on the lower level perceptual task. So from the point of view of this orange agent, its generative process, its niche is the blue agent. The blue agent's niche could be considered to be like the outside world. But that's where you actually get to plugging in essentially systems across the interface. Everything about the generative model, like defining the agent's generative model, is defining your race car, and then you have the track. So you can generate a really sophisticated model, but essentially it's just going to stand freely until you close the loop with something, even if it's trivial, like the environment just hands out random observations and it just soaks up and absorbs the actions. The actions have no efficacy. You could do that. Then the agent's generative model policy selection doesn't matter.
Right. So the context within a dream often just gets like rapidly moved around. So the environment of this like internal representational world is kind of always changing. But then if you're in the process of waking up, it's almost like it's growing, back into baseline reality. You like slowly open up different doors of perception, right?
I like the doors of perception connection, and also makes me think like when things are quote normal seeming, it's like me looking at my desk and seeing a little flashlight. It's like, well, that didn't take inspiration because the flashlight's actually there. And then it's like, but then if it were something fantastical, then it's kind of like, but if it was fantastical and uninvited, then that's a very fine line with like, is that inspiration or is it just delusional? If it's something that's not that others don't see on the desk, It's like, okay, inspiration, but then is inspiration always associated with a positive sentiment? Like motivation, or like with the valence, or with a feeling like something has been achieved or could be achieved? Or, is our definition of inspiration going to include like a persistent anxiety inducing delusion?
Yeah, that's a good point. Like a hallucination. We're not like converging on reality, I think is what you're saying. You guys have done these before, I'm assuming. I'm
But
assuming not usually. You've done this like thought experiment before, this applying this model, but I'm assuming it's not usually in such a abstract dream space concept.
applying active inference models in different settings?
Like just
Yes.
yeah.
Yes,
Practically.
definitely. I'll paste in the chat. Like if you want to see, here's several dozen code examples. These are written by many different authors. And then what the textbook since 2022 and what all this other collaborative work has done has like helped us set up more of that recipe and the procedures around it, so that like within one to few conversations across these different settings for cognitive modeling, like we can actually move forward with a domain specific application,
Hmm.
which is kind of the goal of the textbook. It just, the textbook doesn't take one all the way there, but that's the kernel, and that's helping familiarize with the structure of the model, capacities, some kind of features and aspects of the model. And then anytime you apply it into a domain, this is pretty much what it comes to look like. You just, so, okay, here's the general model schema. Be like, if we were doing a linear regression on healthcare, be like, okay, observations are the healthcare data. Hidden state is the risk odds for this or that. Let's do the regression. This is like that, except there's this downstairs sense making component and the upstairs action selection component. But yes, we did choose a very with time, and then with this, like with all these unknown unknowns, what is the niche? Is the dreamer creating a mental niche for themselves or something? So some useful elements but with some things that are simpler. In If this had been a robot moving on a chessboard, it would have been a simpler model.
I appreciate the this context. It's cool.
Yeah, it's fun. It
Yeah.
is fun. And here's Jens. He did this for his internship in the institute, but he used those figures from Lars's paper. So this was just about time perception, proximate
Hmm.
perception, sensory perception, precision, and then attention on time, yielding a metacognitive estimate of how much time has passed.
It's really cool.
Yeah, it is really cool. And then that's kind of again where the interoperability of these models can be really powerful. Let's just say like this is a very strong time perception, or let's just say we have this and other time perception kernels. Then somebody on the music and aesthetic side has made a music model. Then there's at least a path towards fusing the time and the aesthetics model without needing to perhaps go to square zero for both of them. I'll copy that into the here.
Thank you for that. It also, with the Lars paper that you were talking about earlier, kind of makes me, it leads into a deeper question that I have, because I just don't feel like I have a solid understanding of how time is put into these models. And the relativity thing makes me question how space is put into these models. It makes me feel like there's going to be some kind of heuristic, some kind of motif that models are generally going to have in order to move through their environments that we relate to what we perceive to be time or what we perceive to be space. And so I think that there's going to be some relationship of variables that goes to that. But whenever it comes to the hard definition of what is time, whenever we're talking about this, and I might be overthinking it, but I think that there's still an open question there.
Yeah, I think so. Like for um agents that work in time but don't necessarily have time awareness, like if there was going to be 100 robots and they were just unfolding in time, but they didn't necessarily have to like bootstrap their own time concept, that would be a simpler setting. But then when we start to kind of take the Chris Fields physics as information processing seriously, and if we want to get to the first principles, then we're dealing with agents constructing their own spatial temporal reference frames. And then as the modeler, there's that question of like, how does the modeler or the model sew that fabric together? Like if two agents have different one thinks it's 2 o'clock, one thinks it's 5 o'clock. But then like is the modeler gonna just say, okay, the earlier one is right? Or we flip a coin to decide who's right. It's like, will they even be able to talk to each other? And then if the modeler says, well, yeah, it's 3 o'clock, they're both wrong, then what system are you modeling? If you're modeling how time delusion can coexist, then that's one versus, I don't know. It really comes down to what you're trying to model, and then more of the research and speculation side might take us to what structure could the models have, and then more on like the RX environment side, we'll explore more empirically like what are the nuts and bolts of getting of different time agent specific time systems to interact. But that's that here. This is just sort of the skeleton. Well, okay. Facilitators, time, question mark. In the coming weeks, we'll go to chapter 8, continuous time. So that'll actually be fun, and exit the discrete into continuous time setting. Chapter 9, putting empirical data in rather than just generating synthetic data, fitting with empirical data. I hope by that point, whether with PyMDP or another method, let's like get an example for that. 10's a wrap up. Or if you are going to be coming to the chapter 7, then we have chapter 3 coming up, the high road, chapter 4, generative models, and then chapter 5, neurobiology. So cool. Thank you all.
Thank you so much.
Cool. See you
Thank you.
next time. Bye.